Okay, in this video we're going to learn how to find the coefficients of functions. Okay, and we'll look at two types of functions, this type and this type. Okay, so I have to form an example of the type and what a plot of the data or of the graph of the couples would look like. Okay, so if we have a function that's in the form y equals ax plus b, then something like that would look like something like y equals 2x plus 4, and that would give us a straight line graph. Or we could have a function, a quadratic function, y equals x squared plus bx plus c. That might look something like y equals x squared minus 2x plus 4, and that gives us this parabola shape. Okay, but the important thing I suppose to note here is that a, b, and b and c, these are the coefficients that we're going to look to find. So we'll be given some points on a line, be it a straight line or a parabola, and given that, we should be able to find the coefficients, and when we can find the coefficients, a and b or b and c, then we should be able to generate the original function. Okay, so example 1, page 391, let's look at how to find the coefficients if we're dealing with a line. Okay, so we're going to look at a diagram that shows a graph of the function y equals ax plus b, and here it is up here, and we've 2 points, minus 1, 2, and 3, minus 2. I might make that a little bit bigger. Okay, and we're looking now to find the values of a and b, and we'll use a method. Okay, we know that the point 3 minus 2 is an element of this line here. Okay, so we can say if y equals ax plus b, we can say this is x and this is the y coordinate. We can say y minus 2 equals 3, which is our x value a, plus b. And we can do the same for the other point, because we know that's on that that's part that was been generated by this function. So we can say y, our 2, is equal to xa, so it's minus 1 times a is minus a plus b. So now we have two equations which we can solve simultaneously. So this is equation 1, this is equation 2. Okay, so we write the two equations, and we're looking to cancel, so we have plus b and plus b, so we'll multiply all of this line by minus 1 to give us this line here, and then we'll add them. Plus b minus b, it goes away. Goes away. 3a plus a is 4a, minus 2 is minus 4, so a must be equal to minus 1. Okay, so that's solving using simultaneous equations, and if we sub this a equals minus 1 back into any of the original equations, then we'll find that when a is minus 1, b is equal to 1. Therefore, a equals minus 1, b is equal to 1. If y equals ax plus b, then the function of that line, or the equation of that line, sorry, is y equals minus x plus 1. Let's look at how to find, it's page 392, the coefficients of a quadratic function. So, but before we do that, can we just notice this, that if we have a quadratic equation and we plot a curve, we'll always end up with a parabola. Okay, and this parabola we can see here cuts the x-axis at x equals minus 3 and x equals 2. So x equals minus 3, x equals 2. Now, x plus 3, if we bring this over here, is equal to 0, and if we bring 2 over here, x minus 2 is equal to 0. And these, in fact, are the factors of the equation or of the function. Okay, so if we multiply those two together, we'll actually be able to generate the original function from which this parabola was created. Okay, so the graph of a quadratic function, f of x equals x squared plus bx plus c, is shown. Okay, so we're going to do an example now, sorry. Okay, so we're looking to, here's a graph of a quadratic function here. Okay, and we're looking to find the values of a and b. Sorry, that should be b and c. Should be b and c. Okay, and write down the coordinates of P and Q. So we'll have to find the equation and find P and Q. So how do we do an example like this? Okay. So here's the method. Now just take from me -1, 0 and 4, 5 are points on the line. So minus, as before, -1, 0 is on the line. So you plug in your 0 for y and your -1 for wherever you see x, and you'll end up with this equation here. 4, 5 is on the line as well, so you plug in 5 for your y and your 4 for wherever you see x, and you'll end up with this equation here. Solve those simultaneously, put one over the other, multiply the bottom line by -1, so you can look to eliminate or cancel the c's, and doing that you'll find that b is equal to -2. If you sub that back into one of the original equations to look for c, you'll find that c is equal to -3. Okay? And therefore, if f of x is equal to x squared plus bx plus c, then in this case, with b equal -2 and c equal to -3, f of x equals x squared minus 2x minus 3. So we've simply subbed in our values for b and c into the form. Now we're asked then to find the coordinates of p and q. So if we just look at the diagram again, you'll notice that p, okay, p is somewhere on the x-axis, okay, greater than 0, but its y value is 0, okay? So if we're going to solve this, then we can let the equation equal to 0. Do you remember we said originally we can describe a function as f of x is equal to whatever, or f colon x maps to whatever, or y equals the equation, okay? Y is 0 in this case, we've just looked at it on the diagram, so we can let the equation equal to 0 because y is 0, okay? Y is 0, so therefore f of x equals 0, so the equation equals 0, which means we can factorize the equation, okay? We get the two factors here, and we can let those two factors equal to 0. So let x minus 3 equals 0, x is 3, or x plus 1 equals 0, x equals -1. But from the graph, we can see that x must be equal to 3. So the coordinates of p are 3, 0. To find q, we know that q, its x coordinate is 0 because it's stuck there on the y-axis. Okay, it has a y value and it's negative, but its x is 0. So we can say x is 0, pop x is 0 into the equation, and we'll find a corresponding value for y. So the q coordinates are 0, -3.